All right, so hello and welcome. Here we are, another question. Let's give it a few seconds to make sure the live stream is working and the audio is working. Excuse me. Hello, the live stream is working and the audio is working. Yep, it's going. Nice. So next question is lexicographically smallest equivalent string, number 1061. Let's see how that goes. And yeah, I guess we'll just keep going. See, that was the previous question. I kind of had some idea of how to solve it already, but obviously I made a mistake, so not too bad. Not perfect, but not too bad either. We're given two strings of the same length, S1 and S2, and a string base string. We say S1I and S2I are equivalent characters. For example, if S1 ABC and S2 CDE, then we have A equals C, B equals D, and C equals E. Oh, okay. Equivalent characters follow the usual rules of any equivalence relation. A equals A equals B implies B equals A. Transitivity A equals B and B equals C implies A equals C. For example, given the equivalency information from S1, ABC, CDE, ACD, and AAB are equivalent strings of base string EED, and AAB is the lexicographically smallest equivalent string of base string. What? So this one and this one are equal to this one. So as A is C, that means you could take, well, E is C. So A, B, C, and C to E means A is equal to C, and C is equal to E, so all three of those are equal, and B and D are equal to each other. Okay. A, C, and E. All right. So then ACD is A and C are the same, and D is B is the same. So it's AAB. You could replace C with A and D with B. And these are both equal to EED because E and E, okay, are equal to A. Let's see. A little confusing, but I think I get it. Okay, and this is the AAB is the lexicographically smallest string lexicographically smallest equivalent string of base string. Okay, I think I know what to do. This isn't too hard. Return the lexicographically smallest equivalent string of base string by using the equivalency information from S1 and S2. Okay. Excuse me, I just gotta check the constraints. I think I understand. This is pretty high acceptance rate. Not a lot of submissions though. 1,000 characters for all the strings, all lowercase English letters, and the length of string 1 and string 2 are the same. All right. So equivalence classes are kind of interesting. Using transitivity is one of those things that you can use a disjoint set data structure to efficiently handle. Yeah, I am thinking if there's another way. Yeah, the transitive property is definitely equivalence classes and transitive properties are usually pretty good for. I would just say equivalence classes. Adding elements to an equivalence class is usually pretty good to do. To use. Excuse me. To use a disjoint set data structure for. Trying to think if there's anything else I might want to do with that. That's probably the easiest, quite frankly. That's probably the easiest. Okay. And I actually can go even further and just slightly modify the disjoint set data structures. That way it doesn't use the size as the deciding which element is going to become the parent. It actually just uses the smaller index. Yeah, let's use a disjoint set. I think it's easiest is a disjoint set data structure. So we'll use int dsd of size 26 of all things. I'm going to say struct, or just array. Actually, it's not int, it's dsd array struct dsd, which we said was int I is -1, parent is -1, and size is -1. We don't really need the size for this one, but we're going to use it anyway. And say for each, I is 0, I is less than 26, increment I. Say auto x is array of I. Say xi is, xi is I, xp is I, and x size is 1. Okay, now we have find and find merge. Are the two basic functions. Find just takes an index, and we're going to say int parent and grandparent. Parent is going to be array of index.p, and grandparent is going to be array of p.p. And we could do it this way. While loop, index is not equal to parent. We're going to do a half compression here, and eventually return the index again, or just parent, yeah. And we're going to update. So we're going to say there's going to be index is going to be set to p. P is going to be set to GP, and GP is going to be set to array of GP dot parent. Okay, and that's not the half compression, but the half compression is going to be array of index. Its parent is going to be updated to the grandparent. Yeah. Yes. Yes. Okay. All right, that's fine. That's a half compression. And that's the find. Find merge. A or index 1, index 2. We have constant A is array of index 1 dot. Oh no. Oh yeah, let's do find. So FA is find index 1. FB is find index 2. And we say if FA equals FB, these are already merged, we can return. Otherwise, depending on, so we're not going to use the size, we're going to say, so we can use pointers now to const pointer. Actually, no, that should be a DSD. We could just say X and Y is probably fine. I think I prefer to go this way. I don't remember which way I like to do my pointers. I think I'd like to do it on the left side. Yeah. Yeah, I do. Yeah. It's just going to be array of index 1. And this pointer is going to be array of index 2. So if x of I is greater than x of y, or y of I. Then we're going to swap x and y. Okay. Interesting. Now x of I, the smaller one should be, x of I should be the smaller one. And we're going to merge y of parent equal to x of I. And we're going to set the size. X size is y size plus equals y size. And return. I think that's it. That's all we have to do. I don't know if there's anything else I need to do with, I think you just update the parents and the sizes, right? The smaller value is going to be the new parent. We set the larger value, which is y, its parent to x of I, and then update x of I size to the sum of the two sizes. I think that's all you've got to do for the find merge. Don't think you need to do more than that. Yeah, there's something here with the sizes that you would do. Normally use the sizes, but this is fine. Okay, now I'm going to convert the characters to the indices. Right, it should be clear that that's what I'm going to do. This should be filled also with just a basic DSD struct. To find merge, and very straightforward. We're going to go through S1 and S2 and do our thing here. Next one is going to be C1 minus A, C2 minus A, and I'm going to say find merge, next one with index 2. And then we're going to loop through base string, create a result string, and we're going to say for const char ch in base string, say result dot pushback, or even better than that, it's just plus equals standard string size 1. The character is going to be, it's going to be find plus A of ch minus A, something like this. And this will automatically, the find will automatically give you the smallest replacement, lexicographically smallest replacement that I could find. So something like this will work, I think. How am I doing on time for this one? 14 minutes? Okay. I think I meant to not make that a const. I just forgot. Okay. Something like this. Wrong. All right. Okay. So I got it right on these ones. Got it wrong. Another one. LeetCode program source code. So E and R, E and O, L and P, G and T, C, R, O and A. So that's a lot of, it's O and A, O, A, E, R, S, and then DM and M. So S should be A, not E. Oh boy. You know, I also tend to make mistakes with the find merge as well. Yeah. Oh, it's not index 1. That's why. Done made that mistake before too. Yeah, this function's kind of tricky. I've written it many times, but it's easy to make mistakes with it, for sure. Okay, there we go. That's why. Let me get some test cases. So these are 1,000 each. Let's do 100. 2 strings each of 100. Let's use an awk script again. For I in sequence 1 to 8. Do the following, and that'll be done. Afterwards, we're going to do a echo with 3 things. Echo. And we're actually going to do this 16 times. Well, okay, 8 times is fine. And it's going to be echo with an awk script in there. Which also is going to have a sed script as well. Last character is going to be removed. Say begin. I'm actually going to do a sort of a double loop type of a deal. So first thing is I need to seed, which is going to be date plus %s %n get line seed. And we're going to say srand seed. We're going to say x empty string, eventually print x. Before we print x, we're going to do 2 iterations, right? We're going to also get a size. It's going to be int. Let's do 1 to 100 times rand. Right, that's the size. We're going to do 4. Let's actually do this twice. So int, so I is 0, I is less than 2, increment I. You know what? It's a little awkward, isn't it? Maybe not print. I'm gonna try something else. Let's do. It's actually kind of tricky. I don't know. You know, maybe we'll do it this way. Maybe we'll do it this way. I'm trying to think here. I'm not gonna use the sed now. We're gonna make things a little more sophisticated. So we're gonna start with. We'll start with this character. We're gonna get the size, and we do 2 loops with this size. 1 loop of this size where x is going to be x comma int rand. It's actually going to be a random character, not an integer. Char of int rand 26. I don't know if that works. Yeah, it's actually going to be this comma and x. Huh. Yeah. Say if I is greater than 0, then x equals x with a comma. This is confusing, huh? One is invalid as number of arguments for rand. Oh. Didn't think that through either. It's 26 times rand. Okay. Syntax error. Fatal function char not defined. Okay. Oh no. Ooh. Uh-oh. Uh-oh. Hmm. Hmm. Excuse me. Do that. Whoa. As printf. Is that what I want? As printf cn. Whoa. Whoa. Uh-oh. Uh-oh. Gee. I think I need to add 97. Wow. Look at that. Let's just make this 0 or 1, right? Okay. There we go. 97 I need. Okay. A little closer. And I don't need... Actually, I don't need these. Okay, not bad. Not too bad. So we have this value x. I don't need this echo in the beginning, do I? I don't. I do not. I didn't think about that. Okay. It's good to know that I can do that if I wanted to. How about maybe I want something like following. Kind of want to do this loop, do this twice, this loop. But then remove the character at the end. Yeah, I mean, could do something like that. Maybe better would be to do the following. So X gets now a new line character. Okay. And then how about that actually? Wouldn't that be, well, they just repeat the same code again? I mean, why not? It worked. Hmm. I did this wrong, didn't I? Okay. Not the worst. Huh. What is going on? Do I not need the new line character here? Ah, there we go. Cool. Neat. But I still need one more. I need 3 of these. Oh boy. Okay. All right. Let's try to do it this way. Let's try to. Oops. Let's do another for loop. Oh no, that's the problem. Is that they all need to be the same length, right? They don't have to be the same length. All right, never mind. We're just gonna go ahead and create another one. Whatever, it's fine. Sure. It's kind of funny, but yeah, whatever. 3 of them. I mean, whatever works, right? No. Okay. Didn't like that one. This one actually shouldn't do size twice. Okay. Unterminated string, huh? Oh, I see. Okay. Oh. It's an easy thing to miss. Okay. Very cool. Lots of test cases. I mean, yeah, it works. Hey, got there. Not bad. Let's do another one. and maybe one more. I don't know if I'm sure there was a better way to produce these test cases. I'm sure there's also some more nuanced test cases to look into here. I'm gonna go for it though. I am going to go for it. Let's see if I got it. Hey, you got there. Sweet. Hey, hell victory. 100% too. Not bad. Not bad. All right, that wasn't too crazy. Nice. Nice. Let's submit it 5 times, and yeah, that should be approximately linear time. Approximately linear. I'm gonna go until 22 my time, which is 2200 hours, which is 10 p.m. 2200, just 10 p.m. And we have 1, 2, 3. Just do 2 more. 2 more submissions here, and yeah, this is relatively fast. Uses disjoint set data structure. Very straightforward. That one was not too hard of a question. I think it was not too bad. All right. So what I'll do here is go ahead and restart the stream on another question. So thank you for watching. If you like that, don't forget to follow, and don't forget to subscribe and